Alright, this is your video for the Chapter 5 review questions. This is due Monday. Before the test. Number 1. What you need to know about number 1, a big hint, is an action-reaction pair is two different objects. Number 2. You need to draw a free body diagram or a picture and sum the forces solve for f of t Remember that force of gravity is equal to weight and also equal to mg. So weight is equal to mg, force of gravity is equal to weight, force of gravity is equal to mg. So if you're given force of gravity or you're given weight, then you can figure out the mass by dividing by gravity itself. Force of gravity is not 10. Force of gravity is mass times gravity, which is 10. Gravity is 10. Not force of gravity is 10. Once you solve for f of t, there's your answer. Number 3. I think I did this in class for everyone. It is basically just geometry. You have your inclined plane. It says that your inclined plane is 20 meters, your height is 5 meters. It does not give you your base, and that you have a crate sitting on it. There is no force that is pushing or pulling the crate down the inclined plane, and the inclined plane is frictionless. So if this crate comes down, it is only coming down because of gravity. We tilt our axis in the direction of movement, and so therefore we have to resolve our force of gravity vector into x and y components. So you have your x component here, your y component here. The only thing that's bringing this crate down is the x component of the gravity right here. These are similar triangles right here. This one is a smaller version of this bigger one. So if the only force that's bringing this crate down is x, we can approximate what x is equal to by picking up this triangle and flipping it, and knowing that x is next to the right angle and not next to, and is opposite the angle here. And so if we look at the angle opposite the angle next to the right angle, we can tell that x is approximately equal to 5 newtons, or 5. In this case, it'll be 5 newtons. Here it's 5 meters. So it's just a similar, it's just a geometry problem. Number 4. You need to draw a picture. Sum up the forces. in X and Y direction, both. You need to solve for f of n in the Y direction, and solve for A in the X direction. The things that are important to know here is that 20 newtons is not mass. Mass is measured in kilograms. This is measured in newtons. Also, 0.4 is not F of K. It is mu. Once you have solved for f of n in the y direction, and you've solved for your mass, you can then plug in and find your acceleration in the x direction. Number 5, you have that inclined plane again. This time it has friction, but it doesn't have a force, any kind of a push or pull, bringing it down. It says that it's static friction. And so basically your choices are that it's going to accelerate down the ramp or it's not going to move. I'm going to limit your choices there for you. It's not going to accelerate briefly down the ramp, because once it gets started, it's not going to stop because of gravity. It's also not going to move with a constant velocity unless the static friction and the force of gravity bringing it down are equal. So that could be another choice, but this is what we have to solve for. So basically the only thing that's bringing down this crate is the force of gravity, just like it was in number 3, which has an x and a y component because we always tilt our axis in the direction of movement on an inclined plane. And so we've got f of g right here. This angle is always equal to this angle right there. This is a similar triangle. So this component right here is going to be opposite the angle, which makes it fg sine theta. This one is going to be fg cosine theta over here. And so if the only thing that it could bring this crate down is this gravity in the x direction, because it matches the x component of the coordinate system. So if it's going to come down, it's going to be because of this fg sine theta. If it were to stay up, then that is because of friction, because of the static friction here. And we have a formula for that, mu Fn. So we need to substitute mg in here for this force of gravity, sine theta. We need to figure out what Fn is here by summing up the forces. So you sum up the forces for F in the y direction, and you get Fn minus Fg cosine theta equals 0. And so to find Fn, you have to move Fg cosine theta to the other side. And so Fn is equal to Fg cosine theta. So the thing that's keeping this up, the static friction, is basically equal to mu Fg cosine theta, which then you can substitute mg in for this Fg. So you've got mg here, you've got mg here. So if they both have mg and they're the same mass and they're the same gravity, it's not going to make any difference. So basically you've got a problem here which number is going to be greater, or are they going to be equal? Sine theta. And I meant to put a 30 there. So let's go sine 30 degrees. That's what the problem says. So that gives us 0.5. Here we have 0.5 times cosine theta. So 0.5 times cosine 30 degrees. And that equals 0.43. Being as this number right here is bigger, then the box is going to accelerate. If this number were happened to be bigger, the box would not move. If these numbers were equal, then the box would then move with a constant velocity down the ramp. So you really have three choices. And that's how you work that problem. So you can pause this at any time you need to get any of the work. I'm going to move on. So that was number 5. Let's go on to number 6. Yeah, that was number 5. Move on to number 6. Number 6 is a pulley problem. The first thing that you want to do is you want to sum up the forces. Sum forces for each block. You want to make sure that your A is positive or negative. So it's going to be positive for one block and negative for the other when you set them equal to MA. You're going to need to solve one of the blocks, and it doesn't matter which one block for f of t, and then you'll substitute into the equation for the other block and solve for A. So that's how you do that problem. 4 little steps. And if you need help on setting up sums of forces for pulleys, you need to look at the pulley problems that I did for you. Number 7. The big hint here is the sum of the forces are equal to 0 because they balance. So A is equal to 0, obviously. This only happens in 2 cases, and I taught you both of them. Happens for 2 cases. When is A equal to 0? Whenever you set up the sum of the forces, you set them up equal to 0 or you set them up equal to MA. In what cases do you set them up equal to 0? Number A, 8. Your answer here is going to be E. And I need to go back and give you the answers for those. Number 6 is going to be equal to E. I gave you the answer for number 5. I gave you the answer for number 3. I believe you have the answer for number 2. Number 2 is going to be D. And number 3 is going to be C. Alright, number 8. You want to draw a pick. You need to sum up the forces. And then you need to ask yourself a very important question. Where does acceleration take place? X or Y direction? Because gravity is in the Y direction. Your answer here is D. Number 9. Your big hint here is that static friction keeps objects from moving until a force big enough or strong enough to overcome the friction moves it. So solve for F of S. We have a formula for friction. And it gives you everything you need to solve for F of S. So your answer here is going to be D. Number 10. You need to draw a pick and label the forces for each case. One crate and 2 crates. Then go through and eliminate what is not true. In order to do that, you need to look at notes for what coefficient of friction is. And what weight is. Your answer is A. Alright, I'm going to stop the video for the multiple choice. Be looking for another video for the free response.